Hi, I'm Eric Oseland, graduate student at the University of Missouri. The spread of herbicide-resistant weeds such as waterhemp and Palmer amaranth have required researchers to look into some alternate methods of weed control. One of those is harvest weed seed control in the form of narrow windrow burning. Harvest weed seed control has been widely adapted in regions of Australia to assist in controlling difficult-to-control weeds. Research is currently being performed in the United States to see if these methods could be implemented into our system. For the past 2 years, researchers at the University of Missouri have been looking at how narrow windrow burning fits into our system. In order to do this, a chute must be fabricated and attached to the back of a combine. In this particular study, the chute measures 18 inches across. As the harvest is performed, the soybean residue and weed seeds that pass through the combine are left in a narrow windrow similar to a windrow of hay or other forages. By producing a narrow windrow, the increased density of the residue allows for the burn to be more concentrated and reach higher temperatures. Once the windrow is lit, it burns slowly, and on a not windy day, the fire stays within the windrow and does not spread across the field. Although it burns slowly, the temperatures that have been recorded are quite impressive. The graph shown here is a representative sample of temperature data that was recorded in a windrow during a burn. At a peak temperature of over 600 degrees Celsius and staying consistently over 500 degrees for several minutes, it is reasonable to believe it would have a great impact on weed seed viability. Research performed by the University of Missouri in collaboration with other universities has evaluated the seed rain of troublesome species within each state to determine if seed rain occurs before the soybeans are harvested. As you can see in this graph, the seed of waterhemp plants are still present on the seed head at soybean senescence. The graph shown here shows that at 1 week after soybean senescence, giant foxtail, giant ragweed, and waterhemp have all retained over 70% of their seed. This data shows that with these three weeds, there is an optimal time for weed seed destruction, and that these three species are candidates of weeds that can be controlled through harvest weed seed control. Narrow windrow burning does show promise to be an effective means of harvest weed seed control that can be implemented in our cropping systems. However, there is a lot of research that needs to continue to be done to prove its effectiveness.